good morning, good afternoon, and good evening, and welcome back to another episode of IT Pro TV. I'm your host, Don Pezet, back again with another episode of VMware Certified Professional version 6. Now, in our last few episodes, we've been tackling networking. We saw vSwitches, we saw DV switches, and in this episode, we're going to continue on with DV switches and talk about some of the more advanced features that are baked away inside of them. Now, in our previous episodes, we saw how to get DV switches set up, the distributed virtual switches. We saw what they can do and how you get them in place. And there were two special features that I said I was going to talk about a little bit later. Well, this is that later. So one of the features is Link Aggregation Control Protocol, or LACP. The other one is Network Input Output Control, or NIOC. Maybe you'll call it NIOC, I don't know, but NIOC is what I call it. Those two features are some really neat ones that are baked into the distributed virtual switches. And they haven't been around forever. These are things that were introduced or upgraded in newer versions of the DV switch. For the exam and for real life, we need to know about them because they can actually do a couple of neat things. Let's start with LACP. Now, when I created the distributed virtual switch in the other episodes, in fact, here, let's take a look at what we've got so far, right? So in our story so far, if I go down to my networking and go down to the distributed virtual switch that we made in the previous episodes, when we take a look at the switch as we've made it so far, there's not a whole heck of a lot to it, right? That basically I created some port groups and tucked them away in there and got this set up as a very simple just DV switch that's in place. And one of the things that I did, one of the options that it gave me, if I can get my little summary screen pulled up, is that it gave me the option to add multiple network interfaces to it. And so I did, right? I added a handful of network interfaces to it so that I'd be able to have failover and redundancy. So when we look at it, you'll see like my networks are 3 because of the port groups that I made. And when we defined the ports on those port groups, I added a couple of different uplinks in them to manage them. Now, we can see, actually, you know what, we see it a little better on the host screen. Let me jump over to the host screen so we can see it here and pull it up. There we go. This will show a little better. Let me see if I can't make that somewhat bigger. All right, so here's the distributed virtual switch as we made it. I've got VM sales. We had another VM marketing. There's no virtual machines on it, so it's not showing up here. But we have these physical adapters. And 2 of them are empty, but these top 2 here, uplink 1, uplink 2, those are network adapters that are in the physical host. So I've got more than one uplink adapter in this distributed virtual switch. So what happens when we do that? When you have more than one physical adapter attached to a switch, it does teaming and failover. So when you configure that switch, that's an option that you have to define is how you want teaming and failover to be supported on the switch. Now, the default teaming and failover is actually very basic. The way it works is teaming. The 2 network adapters get combined, and when virtual machines start to communicate, it load balances them. And it load balances them by MAC address by default. So it's taking each virtual machine and it's saying, hey, VM1 goes out the first network adapter. VM2 goes out the second adapter. VM3 goes out the first adapter. VM4 goes out the second adapter. It's just round robin, right? It's not the best form of load balancing because you might have one virtual machine that generates a huge amount of traffic and other virtual machines that don't. But they're being balanced evenly just in terms of sheer number of VMs on the different interfaces. So it's not always equal. It's not always balanced. It's not the greatest way of doing things. That's the teaming side. On the switch side, they just see MAC addresses coming out the different interfaces. The switch has no idea that those interfaces are teamed at all. It just sees different MACs on different interfaces and it responds appropriately. On the failover side, if one link dies, it just shuts it down and then all the traffic goes over the other link. Your switch sees that and relearns the MAC addresses, learns that the MAC addresses have moved to this other interface. So the switch doesn't realize what's going on. It just thinks there's other switches out there. On the distributed virtual side, it's just doing basic load balancing. So the built-in teaming and failover, what's going on right now in this setup, is actually not very robust. LACP, on the other hand, is a different way of doing things. LACP is the Link Aggregation and Control Protocol. The link aggregation, that means taking more than one physical interface like these and combining them into a virtual interface. When it does that, it no longer treats it as 2 different physical adapters. It treats it as one virtual adapter. So when we send traffic out, the traffic is being sent spread across both links, and it's doing it in a way that is very, very evenly distributed between the 2. And more importantly, the switch on the other end, you might have a Cisco or HP or Juniper switch or whatever, it can run LACP also, and so it's aware. It knows that it's a bonded port. So when you have failover, the switch doesn't have to learn the MAC addresses. The switch already knows the MAC addresses are valid on any of the physical ports in that LACP bundle. So we get much faster failover and we get much better load balancing. So that's the link aggregation part. The CP, the control protocol, well, it's a protocol, but control is how we handle communicating with the switch on the other side. Because the switch and VMware or ESXi are going to have to talk and play nice. And LACP is an open standard so that anybody can support it. Be careful because there are some proprietary protocols like Cisco. Cisco has the Port Aggregation Protocol, or PAGP. PAGP is Cisco only, but Cisco supports LACP also. So we want to use LACP if we can because VMware supports it too. Right now we can get the devices talking and they're happy. So that's a better solution than what I've got right here. What I've got, when we set up this DV switch, I just added the uplinks and that was it. It does the teaming and failover for me. And some of those options you'll see pop up in a few different screens, like when I go into some of my settings, usually for the switches themselves. Like if I go back to my switch screens and I take a look at my settings in here, you'll sometimes see teaming and failover options pop up. If I had a regular switch, I would see it. If I jump in, and well, it's buried in here somewhere. But in a DV switch, instead of teaming and failover, we see LACP, right? Because that's what they want us to configure here, is to get that extra support put in place. Teaming and failover is kind of the old way. LACP, that's the new way. All right. So what we're going to do is we're going to enable LACP. We're going to get it set up here. And there's really two different things that have to occur. One, I got to go to my switch and make sure it's turned on my switch. So whoever's physical switch you have, Cisco, whatever, you need to log into it and configure LACP on the ports that we're plugged into. Once that's on, then we go to VMware into our vCenter and we enable it on the DV switch. So I'm on my DV switch here and I'm looking at LACP and it's asking me for a link aggregation group, a LAG. What a LAG is simply a collection of ports, right? I'm going to gather some ports together to put them into a LACP bundle. So I'm going to hit add, and really all you're doing is creating one with a name. It's not asking me for actual network interfaces yet. So I can come in here and I can create a bundle. So I might say, maybe this will be for my, I can create it for the DV switch itself, or I can create it for one of my port groups. Like this is just going to be for sales or just for marketing. So you can come in and define that. When you create these, look down here, you'll see where you can define VLANs, right? If this were just for sales, I could tie it to my sales VLAN. Or if I wanted to carry both sales and marketing, I could turn on trunking, and now it would carry those too, right? So you can set up that flexibility on the link. For me, I'm going to create a link aggregation group, and I'll just call it my DV switch lag 1. I'm just trying to give it a name so I can recognize exactly what it is. And it's asking for a number of ports, all right? Number of ports is talking about how many connections to a physical switch that I've got, right? And if I set it to 2, well, it assumes I'm going to have 2 ports. But with the DV switch, we're spread across multiple hosts. So I could have 2 ports on each host and actually have far more than just 2. Then the mode. Mode is kind of important. LACP has 2 modes, active and passive. All right. With the active mode, what's going to happen is our system is going to fire up, and as soon as we detect link lights, we're going to try and build a LACP bundle. So we're going to try and bundle with the switch on the other side. If the other side fails, then we'll drop down and run them as standalone ports, which is not really going to work for us. So we really want to become a bundle. If you go into passive, your interfaces will come up as standalone ports, and the switch on the other side has to ask us to go active. And if somebody else asks us, then we'll do it. We'll go ahead and build a LACP bundle, but we won't do it ourselves, right? Somebody's got to ask us. Now, the reason I point this out here, you're almost always going to want to go active. That you want it to go active, you want to actively try and create that bundle. If one side is active and one side is passive, you'll build a bundle. If both sides are active, you'll build a bundle. But if both sides are passive, that's where you'll have a problem. One side will never ask, and the other side will never ask, and they don't bundle. So beware of that. Never end up in an environment where both sides are set to passive. You might as well have not turned on LACP in the first place. I'm going to go ahead and set it to active. And then I get to pick the load balancing mode. Now, LACP load balances very effectively. See how it's source and destination IP, TCP and UDP port, and VLAN. It's using all of those things to figure out how to best load balance people, not just MAC address, and that's it, right? So this is far more reliable. But you can change it. You can switch it to MAC address if that's what you want to do, or VLAN number, or so on. You got a ton of options in here. Destination IP and so on. You can pick what method it is that you want, but the default is honestly one of the best, right? This is going to give us very even balancing. All right, so that's going to be my link aggregation group. I'm going to go ahead and say OK and get that created. Now, you'll notice it never asked me to pick any physical adapters. So how does it know what to bundle? The short answer is it doesn't. It doesn't know what to bundle just yet. And here's the reason. Those physical adapters, mine are already in use. I've already tied my physical adapters to the port groups. So if I start yanking physical adapters and moving over here, what's going to happen? I'm going to have downtime, right? I could do that. If this was a brand new vSphere environment, I was just setting up, then I wouldn't care about downtime. It's brand new, right? I could add this in, add my physical adapters and be in business. But if this is a pre-existing environment like mine, I want to minimize downtime as much as possible. So the way we do that is by doing a migration. And the migration is 3 steps. It's actually not very hard. They give us a little wizard that helps us. You'll see that link right here, migrating network traffic to lags. The advantage of doing it this way is you don't get downtime. You move your virtual machines over, and you move your physical adapters over, and they never lose network connectivity. Everything runs nice and smooth. What we're going to do is we're going to take the lag, and that link aggregation group, we're going to add it to our vSwitch, to our DV switch. And when we add it, we're going to add it as a standby. In a DV switch, you have active uplinks and you have standbys, right? The standbys aren't used, just the actives are, unless all the actives fail, and then the standby gets used. So by doing this, we have our active interfaces, and then we have our lag and standby. We can move the active interfaces into the standby, and now when they fail, the standby kicks in and takes over, right? It's been sitting there all along, and you fail right over to effectively the same adapters, and you don't have any downtime, all right? So let's run through that process. I'm going to click Migrating Network Traffic to Lags, and here it shows me the 3 steps. So if you don't remember them, they're all right here. First, it's showing us to add the lag as a standby, then reassign the physical adapters, and then make the lag the active, right? Just 1, 2, 3, we can knock it out. So let me start by making the lag a standby. So when I click on that link, it'll take me to my distributed virtual switch, and this is offering for me to reconfigure the switch, and what I want to configure is teaming and failover. I know I said teaming and failover is the old way, but LACP needs it, so I've got to choose that, and then we'll take over for it. So just choose teaming and failover. We don't need any of the other stuff for this. And then we'll hit next, and now I can pick my port groups. All right. Now when I look at my port groups, well, I need to pick which one I'm going to modify. And so here's where I can select it, and I can pick, am I modifying sales or marketing, or am I modifying all of them, right? I can do them all. I'll just do sales. All right. So I'll choose my sales port group, and now it's chosen, and we'll hit next, and now teaming and failover. Now teaming and failover, see how it's load balancing based on route, based on originating virtual port, or network failure detection. This is all the old stuff. I'm going to ignore that because we're about to move away from it. And then down here, I see my failover order. This is what's important. I've got my 4 uplinks, which from the earlier shows we saw, we actually only have 2 uplinks on these servers. So these other 2 aren't even used. But these guys are active. And then down here is my lag, and it's unused. And what I'm going to do is I'm going to move it up to standby. And as soon as I do that, I'm going to get a warning. See that warning right there? And it tells me using a combination is only acceptable if you're migrating. Well, that's exactly what I'm doing, so that's okay. I'm going to stick with migrating. All right, so I'm going to make it a standby, and I'm just going to move forward and finish that up. And there's the warning about only doing this during a migration. That's exactly what I'm doing. So I'll go ahead and finish it. All right, so now my active uplinks are still active. That hasn't changed. My lag is a standby, but my lag's broken anyway. It's got no interfaces, so it doesn't actually work, but it's a standby, so nobody notices. Now it's just a part of the port group. That's what's really important. So now I can move the physical interfaces down into it, and it'll start to work. So that's the next step. Step 2. We're going to add hosts to it. So I'm going to choose to add hosts, and I'm not actually adding hosts here. What I'm doing is managing host networking, because I've already got ESX host 01 and host 02. I've already got hosts in there. I need to mess with their networking. And so I'll move forward on that screen, and I can pick the hosts, and we can see ESX host 01 and 02. I'm just going to add them both in because they're both part of that DV switch. And then we get to our adapters. Now, I'm only messing with my physical adapters, so I'm going to uncheck Manage Kernel Adapters. I want to leave management alone. I'm just messing with the physical adapters. And then I'll hit Next. And here's where we get to update them. Now, notice VMNIC1 and VMNIC2, see how they're attached to the DV switch, right? They're attached to that virtual switch. And same thing on the other host. What I'm going to do is I'm going to change them so they're assigned to the lag instead. This is where we put the physical adapters into the link aggregation group. So I'm going to choose to assign it, and when I go to assign it, here's the lag. And remember when I created the lag, I told it to create 2 ports. So we've got -0 and -1. I could have done 4 ports if I needed 4, but I just needed 2. So I'm going to take these links and I'm going to move them over to the lag. So I just do it one at a time, which is kind of lame, but it is the way you have to do it. And so on ESX host 01, I just moved NIC1 and NIC2 over to lag 0 and lag 1. And now I'll do the same thing for the other server. I'm going to move it to lag 0 and lag 1, just the same exact process. So even though I chose 2 ports, it's really 4, 2 on one server, 2 on another. The more servers I have, the more ports. So there we've got them set. I'm leaving management alone, right? I don't want to mess with that because I don't want to accidentally lock myself out. And I'll finish it up. I get my impact screen, right, so it's showing that iSCSI will be fine after this, and I can finish. All right, what's happening now is I just pulled the only 2 active adapters out and stuck them into the lag. The lag is standby. So now the active adapters fail, and the lag kicks in. It was standby. And so my virtual machines all jump to the lag automatically. It just happens in the background. It's all automatic. No downtime. So now that that's done, the only other thing I need to do is go and get rid of those physical uplinks so that all I have is the lag. And so that's the last option, the third option here. We'll go right back to our port groups and we'll finish our migration. So just like before, I'm going to come in here and choose teaming and failover. And then for my distributed port group, I'll choose my sales port group that we were working with. All right, so there's sales. And then down here under active uplinks, what I'm going to do is, oh, did I do marketing last time? All right, apparently my lag jumped out. But what I'm going to do is I'm going to take these uplinks, I'll just highlight them all, and I'm going to move them down to unused. And then I'm going to take my lag and I'm going to move it up. I didn't refresh my screen, so apparently it didn't remember the lag was already a standby. But there we go. So now I have the lag as active and everything else has been moved out to unused. So now when I move forward, these settings up here, the load balancing settings, it's only one adapter. Can you load balance on one adapter? No. This is no longer taking effect. Regular teaming and failover is no longer working. Now it's LACP that's handling it. So the fact that there's more than one adapter inside of this lag is kind of invisible to this screen. And so we move forward and finish that up. Now it's going to jump us over and we'll be set up to do link aggregation. So now it's truly active. And when I look at LACP, I'm going to just make sure this is actually finished. It's always important to watch your tasks and make sure it truly completes. And up here, let me just refresh this so I've got the latest information. When I look at my lag and I scroll down here, I can see that it is showing that it's active, 2 ports. We should be good to go there. And I'm just going to come in here and check my health real quick and just make sure I don't have any health status alerts. If anything actually broke, you'd see a big warning here, but I can see it looks like everybody's okay. My VLAN health status is unknown, probably because my switch isn't reporting back, so that's fine. And so we should be good to go there. All right, so now VM Sales is configured to use that link aggregation group. It is using LACP, and now we get balancing. All right. So that's link aggregation and control protocol. Neat way to balance stuff out. If you're using vSphere Enterprise, you want to use LACP. LACP is better than regular teaming and failover. If you're using Standard Edition, teaming and failover is what you have, so you got to use it. All right, the other thing that I wanted to point out in this episode was NIOC, Network I/O Control. And Network I/O Control is just a way that we can get involved in how the bandwidth is managed on our servers. NIOC is enabled by default. It's actually turned on and doing stuff whether we configure it or not, right? Let me show you how that works. So if we dive into our switch, and what I'm going to do is I'm just going to jump back into my vSwitch where I'm at right here. And inside of the vSwitch, if we go into our settings, then we can go into Manage and Resource Allocation. So manage and resource allocation on the distributed virtual switch. This is where we configure NIOC. And when I get in here, you've got two options, system traffic and network resource pools. And system traffic is where we want to start. This is really where NIOC is configured. You can see if NIOC is even turned on by going to our settings page, or I'm sorry, our summary page. When you choose a DV switch and go to summary, you'll see right here whether NIOC is turned on or not, right? It's supported, it's able to run here, and so we should be good to go and use it if we go in and we configure it. And so when I go back to manage and I go to resource allocation and system traffic, right here I can see NIOC is enabled. So it's supported and it's enabled and turned on. All right. Now the way NIOC works is it takes a look at your link speed, right? Your network interfaces. So here it's showing me my total bandwidth. I have a single gigabit adapter that's actually got a link right now. So it's showing me that I have 1 gig of bandwidth. And then what am I doing with it? I have nothing reserved. I have a full gig of bandwidth available right now. So see, I can see, I guess my head's kind of covering that. There we go. So I've got 0 gigs reserved. I've got 1 gig available. It's basically sitting here and doing nothing, right? My server's kind of bored. My maximum reservation allowed is 0.75 gigs. So I can reserve up to 750 megabits of data for a particular service. But it's needing at least 250 megabits just to handle regular system operations and other stuff. So it's up to me to configure that. Right now we haven't configured any of it. But if you look down here, you'll see where it does actually have some default settings. And if you look at the default settings, they're kind of interesting. What you see looking down the list is a list of all the services that generate bandwidth on the server. So you've got fault tolerance, management, NFS, iSCSI, vMotion. All these guys consume bandwidth. And they're set up with something called a share. All right. A share is kind of like stocks, right? When you buy stock in a company, you're buying a percentage of ownership. Well, that's what you're doing here is these guys are buying a percentage of the available bandwidth. The thing is, the available bandwidth changes. So this isn't necessarily a percentage. If something like fault tolerance has 50% of the bandwidth, it would have 500 megabit. But it doesn't have 50% of the bandwidth because all these guys are set to 50 with the exception of virtual machine traffic, and virtual machine traffic is set to 100. So if that was 100%, virtual machine traffic would consume everything. Nobody else would have any bandwidth, right? So the way it works is there's shares. At any given time, one or more or even all of these services could be talking. And so what VMware does is it takes the share count for each service that's talking right now and adds them together. And that becomes the total amount of shares. And it divides that out, and you end up with what you actually get. Let me give you an example. So let's say the first three. So fault tolerance, management, and NFS. So all three of these guys are talking right now. Well, they all have 50 shares. So that adds up to 150 shares. Each one of them has 50 of those 150 shares. They have a third of the shares. So fault tolerance would get 33% of the bandwidth. Management traffic would get 33% of the bandwidth, and NFS would get 33% of their bandwidth. They divide it up, right? So in that scenario, 50 corresponds with 33%. But if a fourth service started talking, like virtual machine traffic, now I've got 250 shares. That adds up to 250. And each of these accounts for a different level of it. Each would account for 20% at that point. Fault tolerance would get 20%. Management traffic would get 20%, NFS would get 20%, and virtual machines would get 40%, right? So shares are not a percentage. They're just a number, and they all get added up, and then they're able to be divided out to find out what percentage people actually get. So you're really setting more like a priority here. And there's 3 macros that you'll see. The macros are low, normal, and high. Low is 25 shares. Normal is 50 shares, and high is 100 shares. So if you have a high priority service, you can give it 100 shares. If you have some service you don't care about, you can set it lower. So for example, notice vMotion. vMotion, by default, only has 50 shares. If I'm trying to fail a virtual machine over to another piece of hardware, it's got to synchronize RAM. And synchronizing RAM takes bandwidth. But right now, it's only got 50 shares. So if I have virtual machines running and I'm doing other stuff, they'll get priority. vMotion will take longer to work. If I want vMotion to work faster, I might want to bump that up and give it more shares so it happens faster. But then when I use vMotion, I might see other things start to suffer. So my management network might get slower, or virtual machines might get slower because vMotion is running in the background. VMware wants your virtual machines to perform as best as possible. They want them to perform at wire speed. That's why they get more shares. But this is all customizable by you. You can take any one of these and you can right-click on it. So I can take like vMotion and right-click on it and choose Edit. And now I can edit vMotion. And I can use the templates. I can say low, normal, or high. And you'll see low is 25, high is 100, normal is 50. Or I can set it to custom. And now I can come in and I can pick my own number, right? And so you can set in your maximum of 100, your minimum of 1, or any number in between, right? So I can set it to 66, right? Or whatever number it is that I choose to put in there, okay? You can also define a reservation. Here's where I can say, you know what? vMotion is so important to me that I want to reserve some bandwidth for it. Then you'll always have that amount of bandwidth available. I don't normally do that here for vMotion, but where I do it, I usually do it for the management network. I want to make sure that no matter what happens, that I can always manage my ESX hosts, right? So what I might do is say, all right, I'm going to bump vMotion up to 66. So vMotion, whoops, sorry, going crazy here. If I get back into my configuration, there we go. I do know how to use a mouse, I promise you. I can see vMotion traffic now is set to 66, right? So it's got more shares. I'm going to take my management traffic and I'm going to reserve a small amount of bandwidth so that no matter what happens, I will always be able to connect to management traffic. So I'm going to edit that one. And under reservation, I'm going to reserve 2 megabits. 2 megabits is not a lot. I'm on a gig adapter. But to be able to access the web interface and to be able to log in and manage it and whatever, 2 megabits is probably all I need. So I'm going to set aside 2 megabits. And no matter what happens, if the server is idle, if the server is slam busy at 100%, there will always be 2 megabits of bandwidth set aside for the management interface, whether we're using it or not, right? So I'm going to set that aside. The opposite of which is a limit. I could set a limit and say, I never want vMotion to consume more than X amount of bandwidth. So, for example, I'll take vMotion and I'll edit that one. And I'll set a limit on it, and I'm going to limit it to, let's say, 900, right? I never want it to consume more than 900 megabits of bandwidth. That way there's always at least 100 megabits available for other things to run and do their stuff. So those are some of the different options we can kind of tweak for NIOC, and now we get that customized, and it starts to work the way that we want it. Now that's part of the equation. The other thing, though, is that it does lump things together, like virtual machine traffic. See how virtual machine traffic, it's all my virtual machines. I might have some virtual machines that are more important than others, and I want to start dividing them up. Well, for that, things get a little bit challenging. So what we have to do there is create what are called resource pools. And you'll remember when we created the DV switches, that you could pick a resource pool to attach to a DV switch. And you can create a DV switch for high priority servers and a DV switch for low priority servers and give different resource pools based on that. So to create a resource pool, you have to start by creating a reservation. So I'm going to take like virtual machine traffic here, and I'm going to edit that, and I'm going to reserve 300 megabits of traffic. All right, so I'm reserving 300 megabits of traffic for virtual machines. And you'll notice it's updating up here to show that I've got this measurable reservation now, and so I've got some memory that's pulled out of the general pool. And now I can go over here to resource pools, and under resource pools I can start to create pools and divvy up that bandwidth. So I can add a resource pool which I'll call high priority servers. All right, and I can come in and I can give them a reservation quota, like a limit of the reservation to be able to use. And so I can give them the whole 300 megabits or maybe just 200 megabits of that reserved bandwidth, right? And so there's going to be my first pool as soon as the screen refreshes. I can then create more pools based on the other priorities of my servers. So while I wait on that, I can create another one, and I'll call this one low priority servers. I gave the other ones 200 megabit. I'll give this one 100 megabit, and I'll create that. And my high priority servers just showed up. If I were watching my recent tasks, it's probably already done. Yeah, my screen just needs to refresh. So let me give it a quick refresh. There we go. So now I've got high priority and low priority servers created. My virtual machine networks already have a reservation of 300 megs, but now I've divided it so that I've got 200 here and 100 here. And when you choose them, down below you can see where they're assigned. So the distributed port groups attached to high priority servers? Well, I don't have any. Or virtual machines attached to high priority servers? I don't have any there either, right? The list is empty. I don't actually have anything attached. Now, I can go to the port groups, or I can go to the virtual machines themselves, and I can attach them to these resource pools. We normally do it by the port group, right? So I might go to my sales port group, and under my sales port group, if I go to manage and look at the properties, you can see the network resource pool right there. So maybe my sales servers are high priority. So I'll edit this. I'll go to that resource pool setting right here, and I'll set it to high priority servers. So now my sales port group will have that 200 megabits reserved for it, and it's ready to rock. And then I go to my marketing, and I edit these guys, marketing people, you know, who wants advertisements. So I'll take their network resource pool and I'll set them to low priority servers. And so now they get 100 megabit. It's a 300 megabit pool that's reserved at all times. 200 megs is now going to sales, 100 to marketing, right? That's not a lot of bandwidth, so in real life you might want to do higher numbers, but just as an example there, we've now divided it up. So when you're configuring NIOC, when you go to the distributed switch and you go to resource allocation and system traffic, these numbers here, they're great. It works really well, but it doesn't give you granular control. The resource pools, that's where you get the granular control, okay? So if you combine the two, now you get some really specific implementations. If you want to go bigger, you can. And the nice part about this is I configured it on a distributed virtual switch, right? So if I have 10 different hosts, these settings apply across all the hosts. All the hosts may have a gigabit adapter or a 10 gig adapter, and now they're all dividing it up the same way because the settings are part of the distributed virtual switch. All right, so that's a pretty good rundown on this one. I think I've kind of run out of stuff to talk about on virtual switches. In this episode, we had a chance to see LACP, the Link Aggregation Control Protocol, which if you have the feature, if you paid for it, you absolutely want, as opposed to doing regular teaming and failover. It's a great protocol. And then we got a chance to see NIOC, the Network Input-Output Control. You may or may not want to use that one. If you really need to make sure that certain virtual machines have the bandwidth they need when they need it, NIOC is great. But if you're not mission critical and you don't necessarily care about that, you can just rely on the default NIOC settings. It'll balance things out pretty well, and you'll be in good shape. Although, I'm a big fan of reserving at least a little bit of bandwidth for the management interface, because I've been locked out before and it's not fun. If you have some reserved, you'll be taken care of, right? That's kind of a nice little thing that I like to do. All right, well, that pretty much wraps this one up. I do hope you guys enjoyed it. Stay tuned because we got more VMware content coming up. We got a whole lot of extra stuff to jump into, but for now, signing off for IT Pro TV, I'm Dom Pezet, and I'll see you next time.